Hello everyone, this is Muhammad. I'm here for a new tutorial on how to make smooth curves and surfaces for the virtual and augmented reality project by the Unity game engine. So first of all, we should know that for having nice meshes, we have many ways. First, for example, we can make our meshes in the external softwares like Blender, AutoCAD, or 3D Max. And we can import them to the Unity. Usually the best format is FBX or OBJ. Or we can make meshes inside the Unity by some techniques. For example, for the surface mesh, we can use the precisional meshing. And for the curves mesh, we can use the LineRenderer. So let's start with some simple example. And after that, we will use the C# code for that. And that will be very nice. At the end, we will have a very nice surface or curves. And let's start. So first of all, this is our Unity software, and let's make a very simple line in the Unity manually without using any code. Let's add the empty game object here, and this is an empty game object. As you can see, there is no mesh, no material, nothing here. Yeah, but you can just change the position and rotation and scale. Let's add the component and write LineRenderer. If you just write line, you can see the LineRenderer option here. And now our game object, our empty game object, now has a new feature which name is LineRenderer or new component. In the LineRenderer, you can see first in the scene, you can see a pink scene here, and here in this side, the right side, we have some options. For example, if you have a material, we can assign a material to this line. We can change the width of this, by changing this line, and other things. For example, if I want to change the material of this line, first I should go to the project. First, create, right-click in the project and create, and we have a first folders, material, click on it. Again, right-click here, create a material. For example, material 1. So now this is our material, and with clicking here, and we can change the color of this material, for example, green. So now for assigning this material to this game object, we can just do this. Or we can go to this game object, click materials, the elements here. You can, if you click on this, you can find many materials here. You can just click on them and just both of them means assigning material to the game object. So right now, one thing for having much better, control on a scene, you should know that we have two, camera. One camera is in the scene, and we are working with that. We are with this camera. Now you can see the LineRenderer, we can see other object, but we cannot see this camera because now this camera, for example, I'm now zooming or zoom out this camera, but another camera is in this camera. As if I now in the scene, I can see it, this camera. And if you go to the hierarchy, you can see it as a main camera. This camera is for our gaming, and is a game object here. And at the end, when we press on this play button, and when we go to the game, everything now we can see here is exactly based on this camera, the camera as an object here. And for example, we can change the position of this camera, and if you see on the camera preview here, you can see our game object, our LineRenderer here as a green object here. And if you go to the game here, game part here, you can see it here. And this is and if you click on it, play button, this is exactly the object with this camera. So in order to use the scene camera, which is now we are using for making our game object, you can press Control, and when you press Control, if you see the mouse is like an eye, and just now press click button, and do not release your hand, and just change the position of the mouse, and this gives you a very good ability to see everything. For example, to see the light, to see to see the main camera, to see the objects. Yeah, this is very important. So now this is our line, in fact. So I can change the name of this from my game objects to another. For example, I can our line. Here, if you click on our line object here, you can see this is exactly the same. So now, what is this exactly? The question is that, what is this? So if you go to the LineRenderer and next go to the positions here in the right side and click on this bar, this is one of the most important part of the LineRenderer. As we can see, the size is 2, and we have 2 options. And if I increase the size, if I change it, for example, to 3 and press Enter, I have a 3, 3 index, and X and Y and Z. It seems it is like 3 points, and these are 3, points in the scene. So where are they exactly? So if you really want to see the points here, just first of all, so it means that our line started with a 0, 0, 0 and ended with a 0, 0, 1, and again there is another point ended 0, 0, 1. I can change it, for example, to 0, 1, 1. Yes, and if you see our line, you can see that our line started with a 0, 0, 0, and next let's go to, for example, as you can see with our directions here, X and Y and Z, this object started with a 0, 0, 0 here, again 0, 0, 1, and at the end here 0, 1, 1. And if you go to the LineRenderer here, and if you click on this here, you can edit the position of the points. These are in fact our points. And if I now, for example, if I change the size, for example, to 4, I will have 4 points, and for example, I can change it to 2, and you can see now change the width. Yeah. Now we have a very nice line, but not a smooth, in fact, but a very, very simple line. Yeah, this is 0, 1, 0, this is 0, 0.1, 0.2, and 0.3. So the procedure is, we should define a point in the LineRenderer. So, and if we define some points in the LineRenderer and change in the position, change the size, and adding some points here in the LineRenderer, our curves will be made. So now the main question is that how we can define the position of the points here in the Unity. So there is no limitation in the number of points, there is no limitation in the positions, but the question is that how we can define the positions. It is really dependent what line you are really seeking for. For example, if you are just seeking for a very simple line, for like a stairs, or you are seeking for the smooth curves. Yeah. So for the smooth curves, we should know the concept. If we go to the Google and search a Bezier curve, we can see that a Bezier curve is a parametric curve used in the computer graphics. Because we are seeking for the smooth curves, we should use the Bezier curve. In the Bezier curve, as you can see in the right picture here, the main curve is a very smooth curve, which, for example, in this shape has a 4 control point. And if you go here, for example, this black line, in fact, is made by the putting many points near to each other. These many points are made by the Bezier curve formulation and with the 3 control points. And when we change the position of this control point to the little bit to the right, you can see the Bezier curve, in fact, is changed. So we have some control points to manage our model. So, and the point is that in the Bezier curve, if we look at the formulation at the end here, we can see that in this formulation, in fact, the Bezier curve is the combination of some points near to each other, and this is exactly what we really need in the Unity. In the Unity, in fact, because we don't have a limitation in the number of points, we just need a very, very good, algorithm for the points to be near to each other and make a curve. So here, in this part, we can have, for example, a specific, number of, points, and the position can be calculated with the Bezier curve concept. Something like this. And if you, for example, if you have a 6 control point, the P0, P1, P2, P3, P4, and P5, this formulation for each t, for example, the t can be defined between 0 to 1. For each t, we can have one position. The BAT is in fact the x and y and z in 3D dimensional or x and y in 2-dimensional, and each t is in fact one of our points. For example, in the Unity, for example, T0 is here, T1 is here, T2 is here, T3 is here, or T0 is this, T1 is this, T2 and T3. So if in the Bezier curve we consider a different number of T, so here we will at the end we will have a position in 3D dimensional and for each T, and we can in the Unity we can just write the position here, for each T. So this is the Bezier curves concept. And now if we want to write a Bezier curves concept in the Unity, we should use C# code. So in order to using code, first of all, we should prepare something. We should have some control points based on the Bezier curve theory. Definitely we should have some control points, and the position of each the points for making a curve will be calculated based on the position of this control point. For example, in this shape, the 3 control points, or for example, in this shape, 4 control points, or in this shape, 1, 2, 3, 4, 5 control points. So first of all, in the Unity, we should define the control points, and after that, we should write a C# code based on the Bezier curve formulation to find each point on the Bezier curves, and after that, just get it to the LineRenderer in the Unity. Let's start. So in the Unity, first we can make a empty game objects. We can name it as a mother example, point. Mother point is just empty game object. There is nothing inside. See, it just I define it because I want to make all of the control points as a child of this game, empty game object, to have a much better, control on all of the points. If I right click on it and in the 3D objects here, right click on the sphere, I can see the sphere here. The sphere here, as you can see, this is just a simple sphere, and this sphere can be just one of our control points. Just again click on sphere and press Ctrl D. This will be our next sphere, for example this position, and again Ctrl D, and for example some point here, for example, yeah, and again Ctrl D for this is the our 4 control point. Yeah, these are our control points. This and because all of them, as you see here in the transform, they have a positions, and we need these positions here this side. So, and as we want to see the curve in the Unity, we should define these control points. So let's start the coding, and based on my last tutorial, at the end when you write a code, you should have one object, empty game object, to assign a code to that, and we name it as a controller. Without assigning a code to any object of in a hierarchy, the codes will not be run. The code is correct itself, but the code for being run should be assigned to something. So let's start. I have written the code I have before, and I just put it in the script folder. I just make a script folder here just to show you. For example, you just click here and just create a folder, scripts. The scripts, I have made a C# script, but you can again right click here, create, and C# script. You can just click on it. If you click on it, this is in fact the main code of Bezier curves based on arrows. So let's start to understand what is this exactly. First of all, we have 4 using line here. It means that we are using 4 libraries, and the 3 of them are the same as others, and I just add this using system library. So let's start. In the public class, for example, this name is exactly the same name as we have here. If you change the name of this folder, you should come back to the code and again change it, because this is really often between the students to see that they just use the different name here as the name of the code, and definitely the code will not be run and you will get error. So let's start. In here, so all of our variables should be defined. So the greens are our classes, as you remember, yeah? And if you see for example, if I just put the mouse on it, you can see class Unity Engine transform. What does it mean? It means that this transform is just a class. It comes from Unity Engine, as we have used the Unity Engine as a library here. Yeah? It means that this class comes from that library. Just to know. Let's start. First of all, I define a mother control points file and as a transform here, and I make it public. When we make one thing as a public, one game object as a public, it means that when we save it again click on a controller. Controller doesn't, the code is not assigned to the controller yet. But if I assign it right now, you can see mother CR points. Exactly, because mother CR points, mother control points is defined as a public here. So for this reason, you can see it here. And this is just for adding the mother points to this. The mother points should be added to mother CR points. If I add it to this, you can see. And what we have, and I have defined a private list vector 3 control points. Control points position. If it's just private, because as our all control points are defined in the mother control points, you know, we don't need again to get the control points from the Unity. If we just get the control points from the mother control points, that is enough. Just I'm using private list vector 3 CR points position. This list vector 3, it means that we have a list of vector 3s. There are many vector 3s inside. This list vector 3s are just the position of the control points, which will be this list will be find by the mother control points. In the continue, I will show you. And I just define a public integer, you know, num. This is just the number of the points on the Bezier curve. As you can see here, for example, we have many points here, the black points. We can define this number of points by ourselves. For example, 50, for example, 40, for example, 100. And when these numbers increase, although this is really, you know, this makes it expensive for the running, but your curve will be more smoother, smooth. For example, if you just use 1t or 1 point or 2 point or 3 points, this is not really smooth. Yeah, and again, because we use it as a public, if you come back here, you can see the num here. For example, this is 0. You can change it as a 50, for example. And next, we have a public LineRenderer main curve. Because at the end, we should use a LineRenderer for representation of the line. So we should define an object, and which is exactly LineRenderer. And we should use this main curve in our codes. And these main curves will have all of the features of any line renderer. As we can see here, for example, our line is a kind of line renderer, and there is I have defined another, you know, private vector 3 RI. This is vector 3 RI. This was list vector 3. Vector 3 RI is just RI which have many vector 3. What's the difference between vector 3 RI and list vector 3? The difference is that in the vector 3 RI you can add or delete the, you know, the members, but in the list vector 3 you cannot. You cannot change the size of list, but you can change the size of vector 3 RI. But I'm using vector 3 RI here as a position on curves, because at the end, in order to fill in this part with the code calculation, we should consider all of these things as a vector 3 and put them these positions in the RI. So let's start to see what we have here. So we don't need void start, we can delete the void start. And as you can see in the void update, we have main curve position. Let's come back to the controller. In the main curve here, we need a LineRenderer. We can define a LineRenderer here, or we can use this LineRenderer as a default. For example, in the controller, we can assign this here to us. Yeah, just dragging this, because this is exactly how the feature LineRenderer. So go to the code. What's the code is doing here right now? Before speaking about the code, just first try to run the code and come back to the scene. This is the camera of our main camera, and based on the things here, these are our control points and this is the curve. And here, if I click on it in the scene, not in the game, in the scene, when I change the position of this point, you can see everything will be changed, everything of the line, because the calculation is changed. Because all of the calculation here is written in the update function. And that is really fast. All of the formulation is here in the update function. So, and as you see here, because the camera is here, for this reason in the game view we are just seeing this. If I click on it and come back to the Unity, and if I click on the camera here, this is exactly what we saw in the game. So in order to watch it much better, just again press Control and put the camera here, and we should rotate the camera right now. Just because the camera is object, come here in the rotation, and just this. Yes, very nice. And again, I can go to here, for example. Again, we have, if I play it, we can see the Bezier curves much better in the game view because the camera is in a very good position. So, but right now we cannot change the position of these control points right now. We should. When it is played, you should go to the scene and just change the position of each point to see what is the code is exactly doing. Yeah, very nice. You can even change the position of point here in 3D dimension, and you can see everything here. So let's go to see what the code is doing. If you come back to the code, in the void update, I have written something. First of all, in the void update, our main curve. What is the main curve? Main curve is a line renderer, in fact. So what will be the main curve in the Unity? As in the controller, in the main curve, we put our line here, this. So here main curve here is exactly this. We just calling this game object, the object our line. So our line dot position count. What is the position count? So if the main curve is this object, so this feature position count should be one of the features of our line. So definitely we should have something like position count here. And if we see here, we should position and size. This is in fact the position count. Yeah, how can we understand it? When we play run here, you can see exactly we have 50 number here. Why we have 50? Because we have written here main curve dot position count equal to num, and num was public, and in the Unity here in the controller we consider num as a 50. So in the our line, if we go to our line and click here in the position, we can see 50 because we assign it as a 50. So and let's continue. If I just click on it again, we'll come back to the scene. Yes. So as you can see, we are changing all of this feature by the code because we define this line renderer, and in the code we have written public variables, and we assign this our line to this code. For this reason, we can change many things by the code, and this is really nice. So first of all, Now the position count is defined. And again, come back to the Unity. As you remember, another thing that should be defined is the positions. Two things was important: the numbers and the positions. So let's go to calculate the positions. For the positions, we need to use this formulation. Pt is equal to this, and this part is exactly the binomial coefficient multiple this things. So we should use this formulation in our code. So let's start how we can use this formulation. First of all, we have a main curve that position curve that count equal to now. Okay. Now I have written a function here, and the function is making list of points. First of all, because in the code we just assign the mother CR points, and mother CR points was in fact this mother points. Yeah, we just assigned this. We didn't assign a sphere 1, a sphere 2, and a sphere 3 to the controller. If you see the controller which the code is assigned to, we have the mother points here. We didn't assign these and these and these. We didn't specify. So what should we do? If we go to the code, I have written a function in the code. This is the word. If you see, if you click on it, you can see. If you just click on this, you can see the making list of points here. This is a function. So I have defined it here, and just use the name of function in the update function. What does it mean? It means that the code will, when the code arrives to this part, making this stuff points, the code, instead of continuing to calculate the curve points, this is another, functions, the code will exactly comes here to see what is the meaning of making list of points function. So in this function, void making, why we use void? Void means that this function making list of points never return us any value. It just do something, yeah, not returning any value, not returning a vector, not returning anything. This means that it is void, yeah. So what's happening here? As you remember, we have a list CR points position. Yeah, here we had a list, CR control point position. We just define a new list. Yeah, CR point position is kind of list. So this should be each time when you change the position of control point in the Unity here. Yeah, each time all of the positions, all of new positions should be recalculated. So each time the control point position, this list should be updated, should be clean and again added, should be clean and again added. Yeah. So CR point positions defined as a new list vector 3. It means that it is new. It is right now. It is new, and there is nothing in there. CR point position, and now in the next lines I'm adding the points to this. Look with the for loop. This is a for loop. For writing the C# code for the for loop, we are using this. For I as a 0 to mother control point position the child count. As you see here, the sphere 1, sphere 2, sphere 3, these are the child of mother point. These are in fact, for the Unity, these are the kind of child of mother point. So what is happening here? I is equal to 0 and I is less than mother control points dot child count. How many child it has? It has 4 child count. Yeah, it means that this for loop should be run 4 times. Yeah, because we have 1, 2, 3, 4. No, so and I++, it means that if I 0 do it means that first consider I0 and do this. Again, consider I1, I++, it means that just added one number. I1, do this, I consider, again add one, another I do this. I2, do this, I3, do this, yeah. Well, so what is happening here? For example, I0, what's happening here? The list we had defined here, a new list, and this list is the list which have a vector series, x0, y0, z0, x1, y1, z1. This list will be filled each time. For example, by writing this code, this list dot add. It means that we want to add something to this list. So what should we add to this list? The position of a sphere 1, a sphere 2, and a sphere 3. These should be added to our list. So how can we define a position of a sphere? A sphere of the child of mother control points. As you remember here, just look. A sphere is a child of mother points. Yeah, here. Spheres are the child of mother control points, and so it means that the code should first recognize the mother control points and get a child. With child, for example, child 0, child number 1. Look at here the I, and child 0, child 1, child 2, child 3. And after that, after getting this object, get the position of that, because CR, control point position pose, is in fact the list of position of that sphere. So first of all, I0, this control point, something will be added to the control point position. I will be 1, something again added to the list. I is 2, I is 3, to I is, yeah. For all of the control points, we should do this. So after that, now our list is okay. Control points position, we know the control point position right now. So now before going to this function, I have written another function which is inside of our calculate curve points function, and we should first define this function. So what is this function? This function is the kalcker function. In this function, get t as an input, just one favorite t, and get the position, point position as a list of vector 3. It means that one list, point pose is the one list which have all of the position of the control points, just the control points. So this function will get a t and get a position of the control points as an input. So, and this function will return us the vector 3. So what the meaning of vector 3? In fact, this function will give us the position of the point with the index t. For example, if we can consider this point, and if we know that the t of this function will give us the position of this point in 3D dimensional. For this reason, the result is vector 3. So, if you look at the code, the I is exactly as the I in this function. If you look at the function, this is the function here, and we have the I is equal to 0 to n. What is n? In fact, we have n plus 1 control point, because I started from 0, and the PIs show us the PI show us the position of the control point. So we should have an n plus 1 control point I. So first of all, I consider I as a 0. This I, this is the I in the equations, and I consider vector 3 result, new vector 3 0 0 0. This result is in fact the position of, for example, one favorite, these points. So I have written for this is for loop. I have written this code that for int j is you can consider j, you can consider any other things, you can change it. J less than point position don't count. and j plus plus, do something. This is exactly, this line is exactly the sigma, the definition of the sigma. Look at here. In this code, we have a sigma here, and which will be started from 0 to n to calculate all of things. So in order to define a sigma here, we should define a for loop, which is started from 0 and it should be finished in the n. So n is exactly the point position plus 1, and when j is less than point position dot count, it means that the final number of the j will be point position dot count minus 1, which is exactly the n which we have here. Well, yeah. So what is the point pos dot count? The number of the control points we have. For example, here we have 3 control points. Yeah. So first of all, we should calculate the binomial coefficient. What is the binomial coefficient? This is binomial coefficient. How to calculate this, in the code? If we go to the this word I have written, this is binomial coefficient. We can write it as something like this, equations. N minus I plus 1 divided to 1 multiple n minus I plus 2 divided to 2 multiple n minus I plus 3 divided to 3, and yeah. So now we can write a for loop, and in each for loop we can write this, equations, and just using multiple. Look at the code. I have written a for loop because we are doing one action, and we are just wanted to repeat this action. These actions, these equations are very similar to each other, if you see. So for calculate these equations, we can write a for loop, and because all of these parts are similar to each other, we can just use a for loop, and in the for loop change just some variables in the for loop. So if we go to this for loop, which is just for the binomial coefficient, for example, I have written that binomial coefficient is this part is in fact like binomial coefficient equal to binomial coefficient multiple to this part, and this part binomial coefficients, it means that binomial coefficient is equal to binomial coefficient divided to kk. Binomial coefficient is this, so is equal to n minus I. As you remember, n is exactly point position dot count minus 1. Yeah. So and it should be minus I plus 1, and we use minus here, and minus I, and minus multiple to minus will be plus, and kk should added one time in each step. Here is 1, here is 2, here is 3. Yeah. So and if you see, we used again kk because 1 is here in our equation is divided to 1, and in the next step the equation is divided to 2. So the binomial coefficient should be divided to the kk, and if you see, the kk will be increased in each step. At first the kk is 1, so 1 and 1. The kk is 2. In the next step will be 2, 2, 2. The kk will be 3, 3, 3. Yeah. So at the end, binomial coefficient will be calculated by this for loop. So what will be the next step? The next step is that, so we know this binomial coefficient, so this should be multiple to ti multiple to this part. So binomial coefficient multiple to 1 minus t power n minus I. Power in the C#, if we use this class, math class, from the system library, if we use this library, we can use one class. The class name is the math, and in this class we have a function which name is po, and this help us to calculate, for example, many things which has, for example, some numbers power to one another numbers. We can use this. For example, if we write, for example, if I write math.po and, for example, 2 and 3, the code will give me, the code will give me 8 at the end, for example, this. So, and you can just search it in a Google too. For example, if I search it, for example, math.po, you can see, for the C# plus C#, and you can see this is one method, and for example will give us exactly the meaning of power. These are all for C#. So minus 1 minus t po to point pose dot count minus 1 minus I multiple to t power I. What is t power I? If we go here and see this part, this is this. So, and all of these things should be multiple to the position of the control points. What does it mean? If we see this is bin, and this should be multiple to pi. Pi is just the list of position of our control points. So at the end, this code will give us, will return us, in fact, the position of each points, each favorite points. When the t is the index of that point. So we know that if I consider, for example, this point, if I consider this specific point or this specific point, right now I can calculate the position of them because I know just the t of them, and I know. But I want to know the position of all these points. So I should use this kalcker function for all of these points. I should just use these kalcker points. So if you look at another function I have defined here, calculate curve point. This is our main function, which I've written it in the update function. You can see the kalcker function here. Because kalcker function just get input t for and control point positions, and for each favorite t will give us the position of that point. So we want to do it for all of the points. In fact, we want to repeat one work for many points. So we need to write this code in one for loop. So this for loop should be started from 0 to num. What is the num? The num is the numbers of that small, points on the curve. And this is, you can specify the numbers. You can say 100, you can say 50, you can say 5, and this is your choice. When we write, for loop for each of these point, we should define t. T will be for example, I divided to the num minus 1. For example, if we consider that we have 50 points here, so what will be the t? For example, for this point, for the t should be the number between 0 to 1. The t can be something like, for example, 1 divided to numbers. For example, 1 divided to 50. The next t, for example here, the t can be 1 divided to 50, 2 divided to 50, 3 divided to 50, 4 divided to 50, for example, yes. And until the last one is 50 divided to 50. This will be our t, because t just should be between 0 to 1, and we can define it something like that. So we define a t. For this reason, we have a t here, and t is exactly based on our curve. For this reason, this technique is parametric based modeling. We use the parameter t, yeah, for all of the calculation. It means that we divided our curves to many parts, and we named this part as a 1t, another part as another t, another part as another t. Yes, for this reason, this technique is parametric based modeling. So for all of t, we should use this function, kalcker function, to know the position of the points, of the small, black points. And after that, so now everything is finished. We know the kalcker. So I have written the position on curve I. For example, I is 0, I is 1, I is 2. For example, when I is 0, the t will be, for example, 0. For example, when the I is 1, the t will be 1 divided to num minus 1. For example, if we consider num as a 50, for example, this will be 1 divided to, for example, 49. If the I is 2, something like this. So, and we have defined the position on curve Ri, vector series Ri. It means that we have a Ri. It has many vector series inside, and after calculation, everything will be put in this Ri, and this will be very nice. So now, after the calculation of the position on curves, in fact, we know the position of each point on the curve, and we should just give this position on curves to the our line renderer. Because as you remember, in the line renderer, we have this part, and this is exactly we need positions of each point on the curve. So with the main curve is just the object, and it's the member of the line renderer class. Main curve is the object which we can use this object to call the line renderer. And dot set position should be one of the features of the main curve. What is the main curve was our line renderer. So, and if we look at our line renderer here, set positions will be exactly this part. And the code, we just say, hey, line renderer, you should use this position on curves and consider them as positions of each point on you here. It means that the line renderer should use that positions here. So, in order to run the code, we should assign the code to our controller. See the controller. Controller asks us some variables. For example, the num is exactly the number of the points on the curve. The mother control points will be the mother points, and the main curve will be this. If I run, in the scene I can see them. In the scene view, if I click on this and then change the position of one point, you can see everything will be changed. Why? Because we have written all of our code in the update function. So when I change the position of one control point, all of these lines will be do again and again. So the main curve position equal to num, making list of points, and this part exactly will be changed the list of the points will be changed. So, and this point effect on this part, calculate curve points, because in the calculate curve points we are using the making list of points. And so, and if I use this here in the start function, use all of our codes in the start function instead of in the update function. So when I run it again in the scene view, when I change the position of the control points, nothing will be happen, because everything is now in the start function and not in the update function. So the changing of the position of the control points will not affect on the all of things, because everything just be calculated one time at the start time, and they will not be calculated again and again during the the game or during the our modeling. This is very important to use the update function for all of things. So I will again here and again save it. And run it. Then come back to the scene view and again change the positions. You can see. So why in the game view we have something like this? Because our camera position is here, and if I change the camera positions here, for example, I rotate this camera, and again change the position. So now with the camera, definitely you can see everything. In the game view, you can see just the position of the camera. This was the whole thing related to having a smooth curves in the Unity, and this is very useful for the surface. And in the next part, I will speak about how to have a smooth surface, which is exactly this concept again. And because the surface is just a combination of some curves together, like a carpet.